Here we are, this is November 1st and we are solving Lead Coast First November challenge. In this we are presented with a linked list which only contains ones and zeros, and we have to convert this binary number into its decimal equivalent. To do this, first I thought of a basic approach to reverse the linked list and to save it in an array and to multiply 2 raised to the power I with it. But sooner or later I modified that and I realized that to store this linked list in an array I must know the size of the array. So anyway I have to calculate the size of the linked list, and while I am doing that I can easily multiply 2 into n minus 2 raised to the power n minus I, so I don't need to actually reverse the linked list, but this problems required me to solve it without any extra space. That means it must be in place, and to do that I had a similar trick. I must just iterate it once so that I have the n, and for each iteration I'll just subtract I from it. So for first I'll multiply 2 raised to the power n minus I, but however this asks me to calculate 2 to the power something, which at its best is a log n calculation. So I'll have to calculate this n times, which makes the complexity n log n, which is more than n, and this question can be solved in n. So there's a basic trick in this. The trick is that if you need to convert a binary number to a decimal number, simply start with a result, initiate it with a 0, then simply multiply that with a 2 and add the value which you have in your hand. For example, if I need to convert 101 to its decimal equivalent, I'll start with a variable result 0 and I'll multiply it with 2, which will result me 0, and the first key that I have is 1, so I'll simply multiply it with 1. So I'll simply add 1 to that multiplied value. So what I will have, result into 2 plus 1 gives me 1. Now my result is 1. Then for the next turn I'll multiply it by 2, it will give me a 2 and I'll add 0, and for the last turn I'll multiply it by 2 again, that will give me 4, and I'll add 1 because I have 1 0 and a 1, and that will give me a 5. So 101, as you all know, is a 5. So this is a basic trick, or let's say if you think about it, you can come up with this, but it's better to know this before you dive into solving all these problems, because this escapes this saves you the time of calculating the power of a number. So that was it. There is another trick in which you could simply use only bit manipulations to do that, but however this and that are almost same. There is negligible time difference, so if you could remember this, this one is better for you.